And here is an application of contour lines. You can see the diagram, and the problem is at all points of curve A. You can see the curve shown in the figure. The potential of the electric field created by point charges Q1 and Q2, assumed positive, is equal to V. So this is a kind of equipotential line. The potential is V. It's a closed curve, obviously it will be. Which of them has a greater magnitude out of Q1 and Q2? Well, Q1 is greater than Q2. And both are positive, yes. Determine the distance L between the charges. This is the main problem. And you can see that the electric field in the case under consideration is symmetrical about the axis passing through the charges Q1 and Q2. And when the curve A rotates about this axis, we obtain a closed surface basically. The potential at all points of which is same, and that is the contour line, though it's a surface. And such surfaces are equipotential. So, and another information is that the electric field, if it is non-zero, at any point of the equipotential surface is directed perpendicular to it. It's a basic concept. And in this case, the electric field does not do work when transferring a test charge from one point of the equipotential surface to another point of the surface. And these are all basic concepts. And you can see here, there is a special point, just name it O, and at this point O, where the curve intersects itself, the direction of normal to the equipotential surface, hence the direction of electric field E, is not defined, because for this curve, for both curves at this point, the direction of electric field you cannot find. You cannot find a tangent at point O, so you cannot going to find normal as well, and E is directed to the normal, to the equipotential surface. So this is only possible if the electric field at this point is zero. And so at this point O, the electric field is going to be zero. And you can write here that if distance is r1, if this distance is r1 and this distance is r2, from point charge q2 to O and from point charge q1 to O, you can simply write here k q1 by r1 square, that is the electric field at point O, is equal to the electric field produced by point charge r2, so that the net electric field at point O is equal to 0. And you know, the potential at this point O can be written simply as phi equals kq1 by r1 plus kq2 by r2. This is the net potential produced by both the charges at point O. And we can use the fact that also r1 plus r2 will be some values, and so, and we perhaps needed to find out L, and from these equations you can easily find the value of L. That is going to be something like k under root q1 plus under root q2 square divided by the potential of the equipotential surface, and you can get the result. And this problem is simple. If you know the properties of contour lines, the problems will become simple. Thank you very much for watching.